Hey scholars, this is Mrs. Gregerson, and we're really starting the basis of geometry. And I'm going to explain a little bit. Remember, geometry is defined as the study of the earth, because geologists study the earth, geography is the study of locations on the earth. So geometry is really the math that makes the earth, or not makes it, but is used to describe it. Well, about 2,500, 2,600 years ago, there's a guy named Euclid. He was a great teacher and philosopher. He thought he was pretty amazing, actually, who had this school, the Euclidean school, and he had his disciples. And what made him so amazing was that Euclid truly wrote the best geometry textbook out there. And he realized that the best way you could start it was with undefined terms. Well, undefined terms are things you just know, you can't define them. Like, for instance, when I say blue, I didn't say the color blue, I just said blue. You can't really describe it, but you know it. Or like I tell a lot of times when I use a biblical example, I'll say God. Well, people try to say he's all-powerful. Well, who's he? What do you mean being? What does that mean? Like, you can't really define him at all. You just know that he's God. And then you have defined terms, and you have things that you can build upon, like blue jeans. Well, blue jeans I can define as denim pants that are colored blue. It's pretty simple. I use blue to describe that. And then we have our postulates and rules. And postulates are statements of fact that are true but cannot be proven. And then we had our theorems. And the theorems are provable facts that we can know without a doubt that they are true, because we can use everything we've had before to help support them. And his geometry is still what we study today. So what you're studying is called Euclidean geometry. It's probably the most practical of all geometries that are out there. But I need you to do a few things for me. First of all, you have to realize you're no longer in Algebra 1. You're going to have to learn to think differently in here. It's a logic class. We have to go out of our comfort zone and use our imagination sometime, which if we're a very concrete person, that's very hard to do. And if you are struggling and you can't see something, I really need you to come in and work with me, and I'll help you to be able to get there. So first of all, I'm going to start off hypocritical. I'm going to help you define undefinable things. I'm going to try to describe it the best way that I can in order to help you understand it, but understand there's really no set definition that I'm using here. Well, the first thing that we're going to describe is a point, and the point has absolutely no dimension. It's just known as a location. And a location just lets you know it exists somewhere. Think of the smallest thing you can think of, and then think of something smaller than that yet. And then imagine that we're not all made of different minerals or whatever, that we're just made of that smallest particle, okay? Because you can locate it there. And the reason why we can even think of points is because we use dots to represent them. We have to put a finite something down to represent it. And so we then label them with capital letters. And so the correct notation is, in order to identify a point, is you actually put PT down, and you always use a capital letter. So if I said point A, you automatically knew where the capital A was, and that's point A. So always use a capital letter. Girls, if you like that lowercase letter, please don't do that. So when I have a point, we have to use a capital letter. We also put a PT in front of it when we name it. Now, your book will not do that. It will instantly stop in time because it takes too much time to put PT in front. But you're not going to do that. You're going to label your points. If you want to pluralize it, you just literally list them all, and you use commas this time because you want to know that each one is an individual point. Okay? So a point, remember, is just a location, no dimension. But we have what's called the set of all points. Now that means everything's included. So for Star Wars fans out there, it's the Force. You know how everything's intertwined? It's the Force. It's strong in this one. Well, it's just the Force. It's absolutely everything. It's every molecule, every breath, everything you take. You're just a bunch of points in geometry terms. You're sitting on points, you're breathing points. You're just a bunch of locations. This what gives us 3 dimensions, because now we can go up, down, sideways, every way that we can, because we're a set of points. So it includes everything, the universe, the stars, the planes, everything that we have. Well, the next thing that we have is actually one-dimensional, and it's a line. And when I say draw a line, almost all of you would sit there and go, phew, yeah, that's a line. Well, almost. A line doesn't stop. What a line is, it's all these points that are put close enough together so that they keep going in opposite directions forever and ever. And I can always add another point. I can always add another point until where I'd eventually just keep going off this page and going forever. So a line is a set of points basically that go in opposite directions forever. So let's write that down. A line is a set of points that extend into opposite directions without end. So they don't stop. So those of you who stopped your line, you're wrong. It needs to go on forever. So what we do to show that it goes on forever is we add arrows. We're not real original, if you know what I mean. We try to keep it pretty much this way. So we always know, and they have to be straight. How do we name lines? How do we identify them? Okay, well, and to identify them, you can use any 2 points that are given on the line. It doesn't matter which one you name first, which one you name second. And in geometry, we're not very original. Our notation always goes with our symbols. So I would name 2 points here, and I'd probably go H and I. And we go line HI. Now here's how I want you to think of geometry. Kind of like in Elmo's World, we go connect the dots. Well, we don't connect dots, we connect points in geometry. So we'll go connect the points. So I have H and I, and if I connect them, I know goes right here, but I use the line symbol on top of it, and it lets me know they keep on going. So I totally can use this one. And so I have line HI, so that's how it reads. Line HI. Notice no comma on this one, okay? There's no comma here. And I could pick any of the 2 points. Any 2 points on this line. Doesn't matter if I go I or H and I can do that. Also though, you can use these little lowercase letters if they're sitting outside the line, and you write the word line out and you list the lowercase letter. That's also known as line T. Allows me to identify it when it works. So let's flip the page over and let's do some fun with these, okay? Now, you can name a line by using 2 points on the line. It has, now, line T here has several different names. Can you think of a few? So in class, I asked you to brainstorm and see how many you could make. Now, some of you started writing right away. Some of you went GH or HG. That's great. And I came up to you and said, that's wrong. And the reason why they were wrong is not the fact I picked 2 points, it was I used the incorrect notation. So then, as we went along with that, we continued, and you could go high or line IH. You could also go line IJ or JI. You keep on going. You could have line GJ. You could have line HJ. You could line JG, line JH. Are you guys starting to see all of these? We could also have line GI or line IG. All of those are names for line T. And remember, you'd also have your line T. Now, those are just some of them. Now, we still, notice, even though there was more points listed there, I never named more than 2. So please do not give me 3. 3 is wrong. I want everyone to hear me on that again. You only ever name 2 points at most when you're naming a line. Do not give me 3. Now, notice I did not use point F or K because point F and K are not on line T, so I cannot use it to work with it, okay? Now, I asked in class, and I kind of went out of order a little bit with our notes because I was curious here. I asked anyone, I go, well, can line F be in a line then? And one of my students just insightfully said, well, yes. It's just not drawn in. Now, that's where I need you to use your imagination. Understand, there's still a line right here. I just did not draw it in. Now, why do I know that there's another line there? Well, it's because of our first postulate. Now, we need to go back and forth here a little bit, so please understand we're going to talk about a postulate here. A postulate is an accepted statement of fact. Now, an example I like to use is our example of our Christian faith. Now, what is the number one postulate of our Christian faith? And many of you go, Jesus died for our sins. No, that's not the number one postulate of our Christian faith. In fact, the number one postulate in our Christian faith is the fact that God exists. God is real. Now, if I went up to you, and let's imagine that I'm an atheist, you're a Christian. If I went up to you as a Christian, I'd ask you, is God real? And you'd sit there and say, yes. And then my question as an atheist would be, well, how do you prove it? How can you prove to me? And well, someone says, well, because you look at how he made things. Hello, I don't believe he exists. How he made things doesn't connect with me. How are you going to prove it? You can't prove that God is real. And then I liked it because I had a student one time sit there and say, oh, Lord, please help her to show her that you exist. What he just did is use his faith because he realized, I can't do it, only God can. So I took a leap of faith and believed that God is real. And then the rest of Christianity, the rest of the Christian faith makes sense. But if I don't believe God is real, I don't believe in Christianity, correct? Well, a postulate's like that in math. If I don't have this rule, if I don't have this basis, the rest doesn't work. And the very first one lets us make lines and make straight lines at that. It's the following. It says this, through any 2 points, there is exactly one line. Now, another way of saying that is any 2 points determine a line. This means the same thing. You only have to have really memorized one of them, but they means the same. So no matter what, if I put 2 points on the paper, and I used my husband's initials in class because I said, hey, put the significant other's initials down, you always know you can draw a line between them. So guess what that means? Over here in this diagram, there's a line from F to H. There's a line from F to G. There's a line from F to I. There's a line to F to J. There's a line from K to J, and so on. There's a lot of lines. So there's an infinite number of lines out there because I can draw a whole bunch of points. So think of this pencil, or this pen, excuse me, as a line. I said it's a double lightsaber that keeps on going forever. Notice it can go in every direction. That means there's lines in every direction. There's lines that are going through you right now. Because it's just a set of points that go on forever. It's okay. But because of points making lines, I know 2 of them will always signify a certain line. That to me is like the coolest thing ever. Now, we're going to actually define a few things right now, and this is a definition you have to know. We use it throughout the year to help describe things. And the first one is collinear points. Notice we have co and we have line in there. Well, that means points on the same line. So we have points that lie on the same line. Now, you will always think 2 are, okay, 2 always are collinear. So when we talk, many times we have to talk about 3, because remember our postulate just said any 2 determine a line. So for instance, here in the diagram above, we know points, okay, G, H, I, and J are all on that line. They're collinear. Kind of simple to think all on the same line. Pretty easy. The non-collinear means they don't lie on the same line. I know, earth-shattering definitions, the first day of class, right? Points that do not lie on the same line. And you must talk about 3 here, because we know any 2 always do. If you don't mention the third, it doesn't work. So you must name 3. So when I talk about points here, an example of this would be if I did G, H, because they're collinear, and then I talk about F. Well, F's not in the same line. That means they're non-collinear. Makes kind of a triangle type shape when you think about it, when you're working with it. And that means they're non-collinear. Now, we have our next one. We have a plane. A plane is a flat surface, okay? Basically, that's all it is. A flat surface made up of points, right? That has no thickness. Now, what I didn't really explain is how I started it. I forgot to tell you, remind you that line is 1 dimension. Well, a plane is 2-dimensional now. I have width and depth, okay? So I know it works. So width and length. So some real world examples of this is like a piece of paper lying flat. How about your desktop? How about the floor? Or a wall? Something that's flat. But remember, it can keep going forever, so you can almost basically end up slicing yourself, you know? It's like it goes on and on forever and ever. So then we have our plane, and we have 2 sets here. We have plane P and we have plane A, B, C, D. We have to be able to identify that. Now, understand we draw a parallelogram so we can give it some dimension coming out, because we have to make it kind of dimensional for us. And if you have no points marked next to that P, and by the way, I think I accidentally put that point there, so ignore that, you would have to name that plane P. But you have to, if you name a plane with points, you have to name it with at least 3. So you'd have to go like A, B, C. And you want to use non-collinear points. And we'll talk about the why in just a moment. But your book will sometimes even do it with 4. Now here's the deal. You only need to name 3. And any 3 on that plane will work. So you could even say, you know, like plain bad if you wanted to, you know, B-A-D. Ray Read is really plain B-A-D, but I think it's fun to say plain bad. You know, why not spice it up a little bit, right? But you have to name at least 3 points. Now, here's the key thing. Make sure they're non-collinear. And here's the reason why. If I am looking at, let's say, a box, okay, and I didn't draw this very perspective-wise, so there we go, a little bit better. And in that box, I have 6 sides, and those 6 sides represent a plane. And I have a point here, I have a point here, I'm going to put C here, and I'm going to put D, I'm going to put E. If I was to say plane ACB, because I named 3 points, notice that plane here and this plane here can intersect at the same spot. Intersects means meet. And they would both share those 3 points. Well, those 3 points definitely let me know which one it is. But the problem is, which plane am I talking about? So instead, I'm going to ignore C, and I'm going to go like ABD here in order to name that plane. It helps me signify the difference. All right, another one that we're working with is coplanar lines. Coplanar means together or with, and plane means on the plane. So it's lines or points on the same plane. And if I said plane means line, I am so sorry. It means plane. All right. Now, looking at this, we would say line AD and point B, you could choose point C too, are coplanar. You could even say that points A, B, C, and D are coplanar because they lie in that same plane. However, if I pick a point down below, let's say it's below it, and I call it E, point E there. If I have point E, do I have coplanar points? No. But if I did that, I had to talk about 4. Because if I can say here, I know points A, B, C, and E are non-coplanar. Because 3 of them make the plane, the 4th one falls off. So that makes it non-coplanar. That's how I know it doesn't work. But I need to ask you a question. Are points B, D, and E coplanar? B, D, and E. Are those 3 coplanar? The answer is yes, they are. Whoa, wait, Mrs. G. That E is definitely not in that plane. I'm not talking about that plane. There's one you can't see. Flip it over again one more time. Let's get postulate 1.4. Postulate 1.4 talks about planes being identified, how to make them. It's kind of like 1.1. It says the following: through any 3 non-collinear points, all right, there is exactly 1 plane. Another way of saying that is any 3 non-collinear points determine a plane. This is why tripods work. Like tripods, you know, like you use to hold up cameras, is because if you put 3 feet on the ground, it's always a flat surface. So anytime you make a triangle, you will automatically form a plane. So that's why they are coplanar, even though that plane was not originally drawn in. All right, so let's finish this up because I've gone too long on this already, so we'll just finish. Actually, we'll pause for a second and we'll get the last part.